So you may have heard that there's a new player on the block. And you're thinking one of a few things. One, you're thinking, oh my God, I spent all this time sweating it out, learning React Native, and now I've got to throw that all away and learn something new. Or you're thinking, thank goodness I never learned React Native. I would have wasted all that time. Now I just can focus on the new technology. Or maybe you're thinking, these APIs, these libraries, they're for the birds. I stick to pure native code, standard libraries. I want to focus on performance, and I don't want to get bogged down in someone else's work. So this presentation is going to have something for all these types of people. By the end of the presentation, you're going to have a good mental model of how Kotlin Flow works, what it is, and how you can use it in your next application. Welcome and thank you for coming. My name is Josh Allen, and I'm really excited about the new features of Kotlin that I'm going to be talking about today. So I think it's important to have a mental model of things so that you can have a good understanding of how to use it in certain contexts. So I'm going to start. There's about 3 different ways that you can think about flows, and I'm going to go through with them now. The first one is thinking about flow as a sequence. Now, sequence is a collection in Kotlin that likely no one here has used. Has anyone here used the? Okay, wow. Okay, 3 or maybe 4 people, so more than I expected. So let's go through that. So first, to explain what a sequence is, I'll start with just iterating a list, which we've all done many thousands of times. So we're going to essentially create a poem, quick brown fox jumps over the lazy dog, split that into a bunch of words. Then we're going to use the map operator. This is a simple list map operator, and we're going to capitalize every word. In addition to, I'm iterating the number of times that map is being called. Then I'm going to do another operator called take, and I'm going to take the first 4 elements. So that's going to be a quick brown fox, and it's going to capitalize every word. It's going to print them out, and then it's going to assert that, hey, that map was called 9 times, because there's 9 words in the list. Very straightforward. Sequence basically fixes the problem that you may not even know is here. But if you look at this, if you look at this loop and you're thinking, you know what, I'm only taking the first 4 elements. Why am I wasting this time capitalizing all the words? So sequence is a way of solving this problem. Of course, another way would be not to use map and take and just write it into a single for loop. But let's just continue with these abstractions because they help building better things going forward. So here we're going to do the same thing. We're going to iterate a sequence. We're going to take this list of words, turn it into a sequence using the as sequence, which returns this collection object. We're going to do the same thing, iterate and map it, print them out. But now we've only done 4 iterations. So essentially, the sequence doesn't do the operators until you call a terminal operation. So in this case, iterating over the poem sequence until it's completed, then that's when it starts to do, it basically combines all the operators into one. So that's a sequence. Pretty cool. Has obviously some real world usages, but not super exciting. Now, flow is a way of, if you can think of sequences, instead of calling as sequences, you're calling as flow. Basically, what it does is it's a sequence that allows you to call suspend functions. So in your map operator, now you can make a network call to fetch the definition of that word. And it's all within the same flow here. There's a little bit of, this is where the coroutine logic that we talked about in the last talk, where we're in this run blocking method, so we're able to call suspend functions within a coroutine context. So we're calling toList, which is another way of what's called collecting the flow, and we're printing the definitions. So this is essentially running asynchronous code in a simple syntax there. So that's the first way of looking at flows. Still pretty cool, but probably your mind isn't blown yet. So I'm going to talk about channels, because we're going to think about flows as a cold channel. We talked about before as channels being hot in the previous actually question Q&A period. So you might not understand, explaining to someone what hot and cold means is actually kind of difficult, but I'll show you an example here. So we're going to create a channel with this channel builder called produce. The way this channel builder works is that inside the builder you call send. So here you can see I'm sending the first 10 numbers we're sending to the channel. And we're calling delay, which is another suspend function, which basically suspends the function or leaves it, or basically returns it back to the calling thread for 100 milliseconds, so which we're pretending to make a fetch. Then we're looping through the channel. We're printing out the numbers from 1 to 10. So every time the channel produces something with emit, it then immediately gets into the channel. And then we have this little trick here, which I'm going to explain why we have here. We're only collecting the first 5 elements. We don't actually care about the next 5. We're just, for whatever reason, we only care about the first 5 elements. And then we're leaving. Now, what happens here? This is in a run blocking method. So I'll tell you what happens. The entire function never completes. It just sits there forever. Why? Because the channel is sitting at this method here called send, and it's waiting for someone to eat it, and no one's consuming it. So it's just sitting there, and you have deadlock. It's not really deadlock. Well, I guess it is. It is deadlock in a way because the code's never going to execute. But that's the issue. That's the issue what makes a channel hot. So flows are essentially a way of it's a safer way to use. It's a safer channel. You don't have to worry about not consuming basically leaving resources unclaimed. All right, so now we're going to create a flow. Has a similar kind of builder functionality. We're basically, instead of send, it's called emit. So we're emitting the numbers from 1 to 10. Here we're calling a collect method. So this is a method. This is a method on the flow. This is actually, most of the methods on flow are extension functions. So when you start using them, you may be confused because you're following a website and it says to use a particular method. You type dot and there's nothing there, so you just got to type it out and click do option enter and import the method. So here we're collecting. We're basically waiting a second again. Then when we get to our 5th element, we're saying basically stop collecting. There's no other way. You wouldn't normally do it this way, but this is one way to cancel the collection. Is you just basically, we're throwing a cancellation exception. You can throw any exception here. It's in a try catch block. So then you come to the end of the collect, and then it does end up terminating because this block, this flow block here is once the collection stops, it's no longer and it's delaying. It no longer comes back into this it no longer gets resumed. Essentially, it just any allocated resources are claimed. So that's another way of looking at it. It's looking at a cold flow. Now, another interesting thing that you can do that's really useful is that you can buffer your, you can basically create a buffer in between the emit and the reading of it. So in between the send and the read. And what that does is it allows the, in this case, the fetching to go as fast as it can and the reading to go as fast as it can. Without buffer, it writes and then it reads. It writes and then it reads. And so using buffer basically uses another coroutine context, and it allows it to essentially be parallel. Allows it to run in parallel, which basically is very useful. Can speed up your program. Now, the most interesting way of thinking about Flow is as a reactive stream. So Flow actually is a reactive stream. There is a library that you can get that will convert from Flow to Rx and from Rx to Flow. So the creators of Flow, they're very open about copying and building on the pioneering work that Rx has done. So yeah, in case you didn't know, reactive streams is a specification that RxJava and Project Reactor implement on the JVM. Of course, it's implemented in a bunch of other languages as well. Flow can also be converted to reactive stream. So let's talk about going from Rx to Kotlin coroutines and Flow. So the first thing is single, which is a concept in Rx, which when you're only returning one single value. So, for example, we're having a login here. With this user API is probably something in retrofit. And then we're basically mapping it to our data model from some kind of JSON object that we've mapped to. And everything's well and fine. If you want to do that without Rx, you don't need any particular special kind of syntax. You just make a suspend function and you're done. And instead of mapping it in a callback, you can just do the call to conversion right there in line. A completable, also an interesting and useful abstraction or class that came out in Rx 2.0. You would normally just have it return a completable, so your logout doesn't actually return any value, it just basically completes. There's no data that's coming back. It's basically an empty response. So of course, the Kotlin coroutine way of doing that would just be suspend with a unit or no return value, and you're done. Now, that was the easy part. What happens when you have an observable? So this is when you're emitting multiple values. So this is where you would want to use a flow. The operators, which I'll get into later, are almost identical. So here, if we're calling our fetch friends using Rx, we're calling get friends. We're mapping it to our data model, and we're calling start with. So this essentially is called a cold observable because it only returns two values. One is going to return the cache, and then it's going to return the real value. So you're basically going to update the UI with whatever's in the cache, then it's going to come back and update with the value from the network. So this is a useful implementation of so this would be a useful implementation of implementation for observable, and then how it would convert to flow. So this flow would essentially return two values and then complete. Now, very often you want to do something called a behaviorSubject, which is awfully similar to a live data. And in fact, I've used this countless times where you have an abstraction that basically wraps a behaviorSubject. This this was, of course, developed before they have live data, but there are advantages to this over live data, which I'll get into. So essentially, you pass in your the initial value. It allows you to get the value, allows you to set the value, and then this is where it allows you to, on the stream function, it allows you to basically monitor updates for that value. And it's done with something called a behaviorSubject in Rx. So this is, to do this in Flow, it's actually a hot flow. So not all flows are cold, although by convention they are. Conventionally they are. So here again, so you pass in the default value. This time we're using a channel called a conflated broadcast channel. Conflated means that if it gets more, if you're emitting more values than you're reading, it just overwrites the last value. So anytime you emit, it just overwrites the latest value. Next time someone reads it, they just get the latest value. We're just getting the value straight from the channel. This is how you emit into the channel you call offer. And then this is where, when you want to use it as a flow, you call channel as flow. So this is a very useful abstraction. Yeah. So what about the operators? So these are the operators that are available to you on Flow. There's map. This is equivalent to map and flat map on Rx. So one of the benefits of using Flow is because it has all of the methods can have suspend functions. Suspend is optional. So if you define a function as taking a suspend function, you don't have to send a suspend function to it. You can send a suspend function or a non-suspend function into it. But because of that, they don't have to have duplicate function overloading. They can just have one function map, and it'll take a suspend function and not a suspend function. Rx, you have to have like map, flat map. They have like the surface area of observable is like massive, more than any one person could understand or remember. There's just so many of them. So that's one of the biggest simplifications. So flat map latest, that's equivalent to Rx version. Catch, this is on resume next would be mapped to that. Flow on, this would be kind of equivalent to subscribe on. On start, that would be like start with. On each identical semantics, retry identical semantics. Single, that would be like, it's called first or error. So why would you bother? Why not just stick with Rx? So if it's so equivalent, what's the, why bother? Well, I'm going to say that the advantages are, there are advantages, they're just not like massive. Like I wouldn't go take an application that's has a lot of Rx code and rewrite it in Kotlin. I just don't see rewrite it in coroutines and Flow. I just don't see the value there. But it is composable, so that means you need less operators. So it is it is simpler than that. Like I said, Rx, because it has so many different, not just observable having a lot of methods, but multiply that by completable, multiply that by single, multiply that by maybe. Each of those, or flowable as well. So each of those classes has its own duplicated API. It is faster. By some benchmarks, it's up to 2 times faster. They have a sample project called Flow Play Scrabble, and the Rx version takes like 23 seconds to run the whole thing, and the Kotlin coroutine and Flow version takes about 9 seconds. It is sequential. So as we talked about in the previous in the previous talk, sequential code is easier to understand than code that uses a lot of asynchronous logic. So because of that, it is simpler, basically because it's using coroutines. And also, it's much easier to write custom operators in Flow. This was one of the big design goals of Flow, was to keep it simple. So simple to write custom operators. So if you ever had to try to write a custom operator in RxJava, it's very difficult because the amount of knowledge you have to have about the contract for reactive streams is pretty intense. So because of that, most people don't do it. But I'll show you just now, what is it like to write a custom operator in Flow? Well, one of the operators that's missing from Flow is delay. You look in the docs and there's no way to just, a value comes into the flow, you delay for a second and then it comes out. There's no way to do that. It's a pretty common operator in Rx. Sometimes you want to do that. So the way to do that in Flow would be, so this is a previous example. You just put on each delay for however many milliseconds you want, and you're done. Now, if you want to look at the code that does this for Rx, it's about 100 lines of code. It's called observable delay, and it's pretty, it looks very, even if ultimately it's not that complicated, it looks intimidating, because you have to know, unless you're a maintainer of Rx, you're unlikely to write a custom Rx operator more than once. So, where do you use Flow in practice? So one way to use it is as a better live data. So we showed before the mutable value. So often you will use live data currently in like a view model, in your repository, in your data source. It is probably recommended that you can just use Flow in the repository and the data source, and optionally use Flow in the view model. Live data does allow you to do data binding, so it isn't a complete replacement. The advantage of using Flow is you don't have to worry about what always being on the main thread. So live data, you always have to be on the main thread. If you've ever used it in your repository, your data source, you know how annoying that could be. Only being able to observe changes and write changes that you're sure aren't going to get lost on the UI thread. If you call post value, you potentially could lose it if someone else overwrites it. Okay, so we showed before canceling a flow to throw an exception while collecting. That's not always the best option, because often you will want to tell the flow to stop rather than the flow itself, rather than the inside the loop knowing when to stop. So how do you do that? Well, luckily, Kotlin coroutines already has a cancellation capability. It does that via coroutine context. So if you ever used coroutines in your view model, you know that there's a view model scope. So that same view model scope can be used to cancel the flow collection. So here, we're essentially, imagine this device status is, I don't know, you have MQTT messaging queue that's sending status from an IoT device, and you're listening to that on an MQTT subscription. Here I'm just mocking it out. So, you know, you're emitting statuses every second. I'm calling conflate. That means that is similar to the conflate broadcast channel. May actually use that under the hood. And it is basically saying only keep the latest status, because I don't care about statuses that I missed. Every time I get the status, I'm going to update the UI with it. And then this is where the magic happens. This is where I'm saying, hey, launch that flow collection in my view model scope. Which means when the view model scope is canceled because the activity is closing or the fragment is being destroyed, it automatically will stop collecting. Now I didn't have to use launch in. I could have used, just put that whole block inside of viewModelScope.launch. The reason why I did it this way is because there's a little bit less indenting, less callbacks. It's really preference depending on how much indenting you want to see versus code clarity. So what is happening with Kotlin Flow? So with the roadmap. Well, so it actually became stable in 1.3. So 1.3.0 was in, I guess they released the first milestone in June, and it went released in August. So that's when it first became non-experimental. And currently for 1.4, Kotlin's focusing on stability and not adding a lot of new features, but there are some features that are in the works for Flow, and the main one is UI and state flow. So a way of essentially like on Rx to be a published subject. So a way of sending events that are only consumed if you're listening. A lot like you do navigation events, for example, when you want to show a pop-up only once in the view model. So that's something they're working on right now. All right, thank you. Any questions on that?
Hi, thank you for the great presentation. We're currently using just live data and coroutines without flows. But, I mean, what would be the most common or most useful use case to bring into the project with flows, right? Like what kind of a construct that you would use only flows for that? Like that would be a great way to start using flows.
I like to use it as a live data replacement in my repositories and data sources. It just allows you to do operator transforms when you want, and I don't have to worry about what thread it's being. I don't have to worry about always being on the UI thread. So I find that the most useful use case.
Okay, but in the UI, so in the view model and fragments, probably not so much.
Yeah, because live data is suited to data binding, it's often more appropriate to just continue to use live data there. Although it can be an option.
Hi, you mentioned that it's easier to design custom operators. Now, is that because the custom operator, since it is Kotlin, is effectively like an extension function, and that's why it's easier?
It has to do with the amount of things being sequential. So the lack of so you don't have to create a new class, for example. There's just less plumbing involved. It just seems like, but if I do anything crazy in Rx, I'm worried that there's some edge case that I missed, and it's likely I did. There's just some, like when I write an extension function in Rx, I usually has to go through several iterations before I get it perfect, because there's might even be like a month later that some edge case came up that like I was like, oh, I wasn't expecting it to be used in that way. Now someone's using it in that way, it broke under that circumstance. Flow, there's less of those edge cases.